Welcome to part 2 of the Oregon FFA Career Development Series for the Forestry CDE. In this video, we're continuing our work in timber cruising, and we're answering a classic question. How do you measure the height of a tree? Without, of course, cutting it down or climbing to the top with a tape measure. Since height is a key part of calculating a tree's board foot volume, we need a practical way to do this. This video will cover how to use the clinometer in order to find the tree heights so that we can then determine the volume of that tree. Other videos from Oregon FFA will cover other tool options.
I'm Jerry Risk. I'm a forester with Roseburg Forest Products. The biggest factors that are going to affect the growth rate of a tree are environmental factors. And these are all factors that we take into consideration when planting a new stand. Environmental factors such as weather, precipitation, how warm the climate is going to be are huge ones. Aspect of a site, a south slope versus a north slope. And another one that I can control as a forester is going to be vegetation management. Trees competing with weeds and brush on the landscape, but also with other trees. And that's where we might have to use a tool like a pre-commercial thin to release those trees from competing vegetation. I remember the first time I used the clinometer in the Forestry CDE, and I was just wondering, when am I ever going to use this thing again besides taking tree heights? And now in my job, we use it on a daily basis. So not only for tree heights, we have lasers to do that as well. But when we're running grades for roads or checking slope of roads or slope anywhere really, we're using a clinometer and other tools on a daily basis too. Diameter tapes for taking diameters of trees, also using them to measure the radius of plots. Lasers for also measuring slope distance or horizontal distance when we're putting in riparian management areas. There's a whole wide array of areas that we're continuing to use these tools that I originally learned in the classroom back in high school and using them on a daily basis now in my career.
The first tool we're going to use is the clinometer. A clinometer measures either percent slope or angle, but for our purposes, we're using percent slope. If you remember the equation for slope, rise over run, this will make sense. When we stand 100 feet from the tree and take a reading, the percent slope becomes an easy conversion. A reading of 50% means the top of the tree is 50 feet above your eye level. Because you're 100 feet away, that percent equals feet. To measure tree height, you'll take two readings, one to the top of the tree and one to the bottom. When using the clinometer, it's important to know exactly where to look inside the device. It's not a scope, it's a measurement tool, and we're reading and seeing inside what the actual measurement is. The first thing to identify is the percent slope side. Inside the viewfinder, you'll see two scales, one for degrees, or at the angle, and one for percent slope. For our purposes, we want to use the percent slope scale. If you're having trouble finding it, try tipping the clinometer all the way up. You should see a percent symbol at the end of that scale. That's the side you need. Once you've located the correct scale, there are a couple of key things to focus on. Let's get a reading. Right now, we're looking somewhere between 60% and 70%. Notice that 60 is actually above 70 on the scale as we look at it, which can be a little confusing. It's easy to make the mistake of thinking you're reading something above 70 when you're actually below it. Also, pay attention to the tick marks. From 0 to 70, each tick represents 1%. After 70, each tick represents 2%. That's important to remember when reading values near the top end of the scale. Once you understand the spacing, line up the reading with the black reference line inside the clinometer. In this example, the line falls right at 67%. Which means the top of the tree is 67 feet above your eye level. Now that we have our top reading, let's move the clinometer down to get our bottom reading. You'll notice that the scale shifts, and in this case, we're seeing a reading of negative 10%. That negative sign indicates the base of the tree is 10 feet below our eye level, hence the 10% negative slope. If you're looking downhill to see the base, your clinometer will show a negative number. Once you have both readings, top and bottom, we can subtract the bottom reading from the top reading to get the total height of the tree above ground level. Now, if we remember our math, we know that subtraction is finding a difference. And if we take a number and we subtract a negative number from it, we're actually adding the two numbers together. So let's go back. We said we had a 50% or a 50-foot reading for the top of the tree. If the bottom reading is negative 20, we would take 50 minus negative 20, or 50 plus 20, and we would get a height of 70 feet on this tree. So what's actually happening here? Let's look at this illustration. In this illustration, we can see that our eye with the clinometer at 0 was hitting the middle of the tree. When we took the top reading and got a 50, we can see that there was 50 feet above our eye to the top of the tree. But that doesn't account for the bottom part. When we took the bottom reading, we found that there was negative 20. In other words, there was 20 feet below our eye that made up the height of that tree, and that needed to be included. That's why that total tree height is actually 70 feet. Let's look at another example. Here, we're taking a top reading and seeing it's around 108%, which means the top of the tree is 108 feet above our eye level. Now, let's check the bottom reading. In this case, it's positive 14%, or 14 feet above our eye level. That means the base of the tree is higher than where we're standing. So to find the total height of the tree, we subtract the top minus the bottom. In this case, 108 minus 14, equaling 94 feet of tree. Remember, the bottom reading isn't always negative. It depends on whether you're standing below or above the base of the tree. Let's take a look at a couple of real-world examples. In this first shot, the left eye is looking at the top of the tree, while the right eye is focused inside the clinometer. What you see here is an overlay of both views at the same time, very similar to what it actually looks like when you're using a clinometer correctly. Each view from each eye gets imposed across the other. That lets you see the reading line imposed over the tree, helping you line it up with the top. In this case, we're landing right around the 120% mark, meaning the top of the tree is 120 feet above eye level. Now, let's scroll down and take the bottom reading. Here, the reading line floats around negative 36% mark, which means the base of the tree is 36 feet below eye level. So to calculate the total height of the tree, we'll do the top minus the bottom. In this case, it'll be 120 minus a negative 36, or plus 36. So 120 plus 36 equals 156 feet tall. Here's a second example, trying to see both what the left eye and right eye would see as we look at the tree and through the clinometer for the reading. As we line up with the top, we can see a reading of about 39 feet, or 39%. Scrolling down to the bottom and lining up with the bottom of the tree, we get negative 41%. So we'll take a top minus a bottom, so 39 minus negative 41, meaning 39 plus 41 gets us a total height for this tree of 80 feet. Once we have the total height, we can figure out the merchantable height, how much of this tree actually is used for logs. We'll explain how to do that in the next video. One of the tricks to using a clinometer correctly is keeping both eyes open. One eye looks through the clinometer to read the scale, while the other eye stays focused on the tree, lining up the reading line with either the top or the base of the tree. This can feel a bit awkward at first and definitely takes some practice. A helpful tip is to hold the clinometer the correct distance from your eye. In this example, the clinometer is held gently with 2 fingers at the very edge, pressed lightly against the eyebrow. This creates the right amount of space, allowing your viewing area to focus on the internal scale while your other eye stays locked on the target point on the tree. As mentioned before, another important factor when using the clinometer is distance. You should stand 100 feet away from the tree. This distance makes it easy to use percent readings, so if your clinometer reads 50%, that equals 50 feet of height. However, not all trees will fit within the 150% range of the clinometer. In those cases, you can move farther back. If you stand 200 feet away, you'll need to double whatever you read in the clinometer. Conversely, if you're only 50 feet away, you'll need to cut the reading in half. That's based on the slope equation, rise over run. So to recap, stand 100 feet away when possible. Make sure you can see both the top and bottom of the tree. If you go to 200 feet, double the reading. And if you're only 50 feet away, halve the reading to figure out the height of the tree. In the Forestry CDE, we'll use tree height measurement as part of the timber cruising practicum. You'll have 3 different tools to choose from: the Clinometer, the Forestry Laser, or the Merit Hypsometer built into the Biltmore stick. Each of these tools can be used to measure tree height. Once we've measured the height of each tree and converted that into merchantable logs, we'll combine that information with the tree diameters, covered in the previous video, to calculate the board foot volume for each of the 5 trees included in the practicum. You'll have just 40 minutes to cruise all 5 trees, calculate their volumes, and then determine both the plot volume and the per acre volume. We'll go over how to do those calculations in the next video.